Hello everyone, this is your daily dose of scientific literature, and today we are going to be discussing this paper from 2008, which was about the BCI Competition 3 Dataset 2 Ensemble of SVMs for BCI P300 Speller. So in this paper, basically this relates to a brain computing interface competition which took place in 2008. And the second dataset was about P300 character speller. So basically, there are two subjects in the dataset who were uh, shown this grid, and their EEG signals were collected at this point of time. And this grid, either a row or a column, flashed randomly, and the subjects were asked to spell a specific word by focusing on one of these characters. So let's say I want to spell India. So I'll focus on first I and then N and then D and then I again and then A. Like this, both the subjects recorded a total of 185 words. Sorry, 185 characters, of which 85 were used for training and 100 words were given for testing, and those 100 words were not available to these authors because it was a competition. And how this works is, if a person focuses on a row or a column which flashes, so let's say I was focusing on N and this entire column flashed up as it is in this snapshot, then after 300 millisecond, uh, a spike is expected to be seen on the EEG signals of our brain. So this spike, as you can see in this red diagram, red line, this spike has been shown. Unfortunately, without P300, there is also another spike, and there is a subtle difference between these two, and that is what this paper tries to differentiate. Now, the data set has been collected like this. So for each different character spelling, uh, the same character was focused on for 15 epochs, and during each of these 15 epochs, all of the 12 rows flashed once in a random order. So there are 12 flashing in each epoch times 15 epochs, which makes it 180, times there are 85 training examples and 100 testing examples, and this was collected with 240 hertz signals, and it was filtered for noise from this 0.1 to 60 hertz. And since this was collected in North America, I'm presuming, so 60 hertz would be the line noise, so this should take care of the line noise because it is filtering. And the EEG 64 channel EEG electrodes were used. As you can see, um, among the 12 data from each epoch, only two are expected to be the positive class. All of the others are expected to be the non-P300 negative class. Two because one from the column and one from the row. So there is a data imbalance at the onset. So that imbalance has not been taken care of in this paper, but they have used a separate method. To reduce the noise, the effect of noise, they have used this ensemble of SVMs, and which has considerably improved the accuracy. They have downsampled the data to just 14 samples so that sample 7 or 8 of each channel corresponds to the 300 millisecond data point. And thus 14 times, then there are 64 channels of the brain, so the column size of the data set is 896. while the row size of the training data is 15300. For the testing, it's 18000, that is 18,000. And then what they have done is they have um, separated this training data 15300 into 17 different parts, each part containing 5 character spelling. So from there they have trained 17 different um, SVM, linear SVM models, and after training they have passed the testing data into the 17 different classifiers, and they have added up the results in such a way that it retains the probability value, and it's not just the prediction 1 or 0, it retains the probability value, and that has had a significant effect in them beating the competition. Because if you add the probability value, you can take care of the confidence. You also get information about the confidence of the model. So if the model is really confident, it would be very close to 1, and if it is very inconfident, the probability value would be very close to 0.5. And that would naturally give a lesser weight to noisy data. And that is what has given this paper or this work an edge over the competition. They have also discussed a feature selection algorithm which uses a recursive channel elimination, and these were the results. They found the highest accuracy of 96.5, which is a mean, and with subject A it was 97%, with subject B it was 96%. Yeah, that's it. Thank you.